Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 21st, 2025. So, about a week ago. This paper introduces a new framework for deep research agents that achieves a 74.5% win rate against OpenAI's deep research on the Deep Consult benchmark. The paper is titled Deep Researcher with Test-Time Diffusion, and as we'll see, its approach is directly inspired by how humans actually write and revise their work. The core idea is to treat report writing like a diffusion process, starting with a rough draft and iteratively refining it. Also, the authors shared their implementation on GitHub. It's structured as a plugin for a system called opt-ILLM. In the repository, you'll find the core research engine, along with a really detailed README, code examples for getting started, and even some sample reports generated by the algorithm. Alright, so here's the first figure, and it really visualizes that core human-centric approach I mentioned. You can see a cycle here, starting with planning, moving to a rough draft, and then entering this loop of searching for information, editing, and revising, which all leads to the final draft. This entire process is the inspiration for their framework, which they call the Test-Time Diffusion Deep Researcher, or TTD-DR. The key insight is that writing isn't a straight line. It's this iterative refinement, a process they call denoising the draft, that they've built into their AI. Building on that idea, this next figure shows us the full Test-Time Diffusion Deep Researcher framework in action. A user query kicks things off by generating both a research plan and an initial noisy draft. These two pieces then guide the search process. The information found during the search is used to, denoise the draft, making it better. This refined draft then guides the next search, creating a continuous feedback loop. What's also really interesting are those little stars. They represent a self-evolutionary algorithm, which optimizes each individual step to improve the final report's quality. This next figure compares the Test-Time Diffusion Deep Researcher to other open-source agents, and it really clarifies why their approach is so different. You see, other methods are more linear. They plan, search, and then write. A more advanced one, Open Deep Research, researches each report section separately, but that can cause it to lose the big picture. The new approach, shown at the bottom, maintains a global draft that gets refined. It also uses a system for retrieval augmented generation, which means it synthesizes precise answers from documents instead of just saving raw data. This whole process preserves context. Okay, so moving to the results. This table shows us how the Test-Time Diffusion Deep Researcher stacks up against other major systems. For long-form tasks like long-form research and Deep Consult, the metric is win rate, which is a direct comparison against OpenAI Deep Research. And here, their model wins big with a 69.1% win rate on one and 74.5% on the other. For the other benchmarks, which measure correctness on complex questions, it again leads the pack, scoring higher than all other agents, including OpenAI and Perplexity. This next table then really breaks down why the model is so effective. It's an ablation study, which is a way to systematically test the impact of each part of their system. You can see that a base LLM, even with a search tool, just doesn't cut it. Then, they add their backbone agent, which helps. But adding that self-evolution algorithm provides a huge jump in performance. Finally, adding the diffusion with retrieval process, that iterative denoising we talked about, is what pushes the scores to the top, showing each piece is critical. So, to wrap up, this work really shows that by mimicking the human process of iterative drafting and revision, and combining it with self-evolution at each step, we can create significantly more powerful and coherent research agents. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.